I will give you an introduction to our project SecureShare. It's about distributed networks with a trust layer. For an introduction, I will show you how people normally communicate. We talk to each other in several constellations, directly or in groups, but everybody receives the message more or less directly unless we're talking over some proxy like a lawyer. But this is not the normal case, and we don't like talking to other people over lawyers. What we right now have on the internet is something like this, where we all talk to each other over intermediary nodes like mail servers, Facebook, Twitter, some kind of centralized infrastructure where we just connect as a client. Whether this in the center might be a server or a big server farm or a cluster or a cloud or whatever, we don't care. As long as it's centralized, it's not the way we really want to have it. We want to flatten the hierarchies. How do we want to do it, or what do we want to do? We want to transfer anything like we can do right now, just decentralized, whether it be messages to single friends, groups, subscriptions like status updates or files. We want to do it distributed. We also want to have resilience in the distribution, because right now if you have one server and several citizen groups or mailing lists have the infrastructure there, if this server gets taken down or seized or there's a power shortage, all the people using this server lose all the infrastructure, and this is not a good thing. We want to have redundancy in our network so that we don't get into problems if one or two or several hundred, in the best case, strong nodes go down, whether it be end users or strong nodes like servers in universities or data centers with lots of bandwidth and lots of memory. We also want privacy. We want to make sure of this by encryption, end-to-end encryption for single user communication in groups. And if you want to have something public, you just don't encrypt it so everybody can reach it. So we don't make sure of the privacy by some arbitrary obscure settings in some database who got write access or read access or not, but we just make sure by the privacy by encryption before we send it even to the network. The ultimate goal would be having the multi-party OTR capabilities with encrypted communication, authenticated communication in the session, and repudiability afterwards. But this will not happen so quickly. The first thing would just be to distribute group keys with the private key infrastructure, so we would have at least encrypted communication, but not authenticated or repudiable, because we don't sign it. Then we want to have scalability. If we look at the current models we have, which is pretty much always round robin, like with email or with XMPP, we run into problems with scalability pretty fast. A friend of mine has a mailing list for party announcements in Berlin, and it has 3,000 subscribers. In the worst cases, it runs for up to 12 hours just to send 3,000 messages out, and we don't want to have this. A friend of us sent us some statistics. He's an admin for some big Jabber servers, and 70% of the Jabber inter-server traffic, so where status updates. I'm offline, I'm online, I'm away. Just status updates. No content there, only noise, only overhead, because it did unicast. You had to tell every single server, this user is offline, this user is online, and then all the single servers had to tell it to their users, which sucks. We don't want to do this. We want to have something like this, multicast distribution trees. We are, for example, this tiny single node. We don't have lots of bandwidth, we don't have lots of memory. We just have shitty ADSL or 3G in the middle of Congo, in the worst case. And we just have a small connection, but we reach a really strong node, like a server or a better internet connection from a buddy from us. So he then or her can distribute it to other friends who then distribute it onwards. So we only have to connect to the people that we can reach easily, and they then distribute the storage further for us. So the end goal or the ultimate idea would be, you're in Congo, you have low bandwidth, but you have like war crimes are happening in front of you and you can only stream it with your smartphone. You don't have bandwidth to serve 5,000 clients, and probably the streaming servers would get taken down because of arbitrary, unfriendly legislation. So you just stream it to a friend and then he or her streams it onwards, and we have citizen television, radio and news in a distributed, resilient way that actually scales. So what's also really important, we want to deliver an API for application developers. It should have around 12 function calls, like open connection to user X, open connection to group X, put something to the distributed storage, get something from the distributed storage. We want to hide all the underlying routing and cryptography complexity from the application users, and in that way also from the users, because users don't care. They just want to get files across. If we can reach them that they want to use a morally better alternative, if you want to say so, then we at least don't want to bother them with the complexity. So the hope is, with the easy-to-use API, we can get lots of application developers developing on our framework, and we also know that we have to get the good designers, because if our grandmothers cannot use it, our grandmothers won't use it, and 80% of the Facebook populations have the technical skills of grandmothers, I suppose. So this is actually the group we're aiming for, everybody. So how not to do it? We shouldn't trust in servers, because servers can get taken down easily. Memory can be analyzed by bus sniffing. If you have VPSs in a hosted operating system, it's even worse. They can just be fed bad random data by the host operating system, and so you get bad cryptography. You can also just dump memory. It's a really bad idea if you only trust in servers, because it's so highly centralized and it's gotten more and more unsecure over the last decades. We also don't want to do encryption from end to end in the browser, because if we don't have anything installed on the client, the keys have to reside on the server, and the best we can do would be typing in a passphrase. But if you then get a tainted interface, because the server you get the interface from is infected, your passphrase is lost, your keys are lost, all your communication is lost, it's a bad idea. SSL is broken. Don't try to do really secure end-to-end encryption in the browser. We have enough trouble doing it not in the browser. Doing it in the browser would just be worse. Yeah, the technologies. We want to use GNU-net as the peer-to-peer framework for the routing and the encryption. It's developed at the TU Munich. It started out 10 years ago as an anonymous file sharing platform, but it got bigger and better, and now we have lots of different transport options and lots of cool applications. For example, we can use TCP, UDP, HTTP, and even Wi-Fi layer 2 routing to mesh. So if this goes on in the direction it's going right now, it will be really awesome pretty soon. And it does a lot of work. It's really modular, and yeah, this will be the basic peer-to-peer infrastructure. On top of that, we want to use PSYC. PSYC is a multicast binary stream compatible chat protocol. Well, chat or arbitrary file streams, because it's binary compatible. And with that, we want to implement the trust layer on top of this and the overlay multicast to actually make it scale. Because IP multicast, as we know, doesn't work yet really well. And yeah, with that, we want to create the multicast contexts to which you subscribe. So in the concept would be, you have a channel, you create a channel, and then everybody just posts arbitrary content to it. Whether it's a message or a file, for example, if you're a musician and you have a new song, you just post your song to the channel, and everybody subscribing to the channel gets a copy to his or her machine. Because you have the trust in the network, you don't even have to click accept this file, accept this message, blah blah. It just shows up in your SecureshAre folder or whatnot, and then you get a notification when it's there. And the limit is only the bandwidth you have. Yeah. Who's in it? Carlo von Lynx had the original idea and was the developer of PSYC for the last years. Gabor Adam Toth is now our main backend developer. Matthias Baumann is also involved with PSYC, And I'm Daniel Reusche. I'm doing this talk and some designs for the platform. This is our URL. And do you have any questions?
So what you presented now is a kind of concept. My question is, how much of it is ultimate real?
Well, we have a prototype and it already does single-user chat over peer-to-peer encrypted with really slow latency. But it starts working right now, and we guess if we can get the 5 developers we're counting with, we could have file transfer and message subscriptions in a year or 1.5 years. That would be the goal.
What type of multicast overlay topology are you aiming for?
We right now have a topology with Psych. You create a channel and you are the master node then. So everybody subscribing to the channel has to send the message to you, and you then distribute it to the first nodes and they distribute it onwards to the rest of the multicast tree. This is not yet optimal, this is just the start. We're aiming for having it so that it meshes fully. Right now it's just a prototype, so we have at least one master node per channel. If that goes down, the channel infrastructure is not working, so this is the current state. But yeah, the aim would be make it fully meshed, so we don't have any master nodes that are necessary anymore. Or at least make the master nodes easily interchangeable in, for example, if the master node goes down.
How would you deal with traffic analysis or uptime analysis?
Right now we don't hide so much of our traffic, it's just encrypted. It might be possible with the upcoming mesh routing module of GNUnet to do some fancy tricks there, for example playing with the timing. I get a packet and I just wait for a while until I send it on, or I mix the order of the packets that I get to reroute them. We can also do packet padding, so we don't have protocol analysis so easily done. In principle, it would be also possible to do some kind of onion routing, but right now our focus is not so much on anonymity as on resilience, on security. So we don't know which features GNUnet will get in the next years, but we're just building up on the infrastructure. It's pretty modular, so if we get some useful modules, it might be feasible to implement them. But it's not the main focus right now. It would be really nice. We would like it, for especially like optional, having paranoia mode, for example, that you say, okay, I want to have all my packets routed anonymously, so my latency gets worse, but I'm more secure. But right now the use case is more not really oppressive regimes like Syria, but more Western Europe and the US with more privacy.
I understand you are setting up a mesh network. As far as I know, mesh networks don't scale pretty well according to the routing tables. How do you get rid of this?
We're not really setting up a mesh network. We're having a peer-to-peer infrastructure, and right now we just have the social routing. So you have your friends, you exchange the public keys and the GNUnet addresses, and then you pretty already know much of the topology. And as you have the social connections and not only relying on anonymous meshing in the neighborhood, we think we can make it perform better because you have the gossiping of your neighboring nodes, but you already know more of the routing table because of the social graph. You want to actually save lots of the routing table on your hard disk, depending on who your friends are. So we hope we can mitigate the problems that come up with random nodes with the trust graph, because you have your friends and some of your friends have servers, so you know these servers are online most of the time, have lots of uptime, so you can just ask the servers, where are my friends, because all the people are connected. And in my trust graph, we could even, in the extreme case, work without any servers, because statistically, if you have 150 friends, 10 of them are online at all times. So all the people just tell them their current IP addresses if they come online, and if you were offline and come online, you can just ask all your friends, hey, do you know where my other friends are? So you can mitigate this problem there.
Okay. I ask you, are you aware that the powers, the political powers of the internet is against privacy? They don't want privacy. You see the example from Skype, the US government forcing this company to turn down Skypecast because they thought it is political beyond their control. And when you open up a discussion based on pure technology, the political space that you implement your work is not the moon, and the real powers of the world are against this out of control network.
Yeah, this is a political issue that cannot be solved just with technology. We have to work on all the tracks at once, and we are just trying to develop a resilient infrastructure and making it like harder to attack because we open source everything. And as we have lots of modularity in the transports, we hope it will get hard to block all the traffic, because you can just choose another transport, set it up on whatever obscure protocol you have there. So I think there might be a possibility to win the arms race, but I would like to end the arms race on a political level, because if we just keep fighting on and on, it will end really badly, and we don't want this. We have to take care on another level. We cannot fight social issues with technical solutions. It never works.
Thank you very much. How do you think you can prevent some abuse of this network?
The abuse we hope to prevent with making everything open source under the AGPL. So even if you would set up a big node and let everybody just connect to it with a web interface, you're perfectly free to do it. Or your users would have less security because they would probably store the keys on the server. But with that, we at least have the legal means to prevent people injecting backdoors into some add-ons or whatever. And the abuse in the typical way would be guarding against intelligence. So you would have to actually trust people that want to spy on you, to put them into your social graph, to actually route packets to them. And if you do that, we cannot help you. Because if you trust people that are not trustworthy, they will spy on you, whether you use the internet or paper mail. Yeah. Maybe we should just all come in front and put the microphone in the center or something, so... Or like that.
Okay. So what communication services do you plan to replace? So mail, is messaging, or just everything?
Our plan is just to create an arbitrary communications infrastructure that is distributed. So you can pretty much do whatever you want. You can replace email, you can replace IRC, you can replace, in the future, trademark, YouTube, if we have the bandwidth, for example. It's just... If you want to put it really coarsely, it's BitTorrent with friends. So, and binary transport, so you can really do whatever you want, not just files. You can also do streaming, push to talk, audio chat, telephony, all encrypted. This is the ultimate world domination goal, actually.
So basically, you provide a foundation, and others have to come to implement these services. If I understood you right.
Yeah, more or less. With the prototype we want to get out, we would love to have an interface for single-user chat and multi-user chat and file transfer. But on top of that, you could pretty much set up everything you want.
And do you plan to provide interfaces to existing infrastructure like IRC, Jabber, or something? Doesn't make sense for you.
SIG already has interfaces to IRC and XMPP, and it's pretty extensible, so you could probably also create interfaces to or gateways to other protocols. There shouldn't be any problem.
Who's next?
Other questions? No? Okay, yeah. Thank you for your attention. Have a good time.